Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 3 of the December LeetCode challenge. For the past 2 days we are having easy questions and today we are having the medium question, but again many claim that this is again easy question. We will see that. So let's quickly begin to a discussion. So if you see it's 2109 adding spaces to a string. Okay, so what is happening is, if you see here, let me just give you a guess, then we will go to the actual theory of it. Okay, so this is a string given to you. Okay, here we have to follow zero indexing. Okay, if you remember yesterday's question, we are following the one indexing. Okay, so but in this case we have to follow the zero indexing, that is the first character will be zero, zeroth index, and so on. Okay, so in this case, if you see, we are given a space array which is integer array, and in this case we are given a string. Okay, so what is happening is, they are saying, in see, for example, first thing is you have to start with zero indexing. Okay, next thing is, at these indexes in the string, that is in string s. Okay, in the string s, if we have to go to these indexes and you have to insert a space. Okay, after that you have to return the result. For example, if you see Leetcode, if you see after that, that is they are saying the eighth index. Okay, if you see 0 1 2 3 4 5 6 7. Okay, so the e of the Leetcode is actually in the seventh index, so they are saying in the eighth index they want a space. So something like this. So you'll have to insert a space here basically, and then so on and so forth. Okay, so all these spaces, all these particular indexes, we have to insert a space, and then finally we have to return the string. This is the question basically. So if you see the constraints here, they are saying it will be slightly bigger. Okay, it is around 10 power 5, 3 into 10 power 5. And only good thing here is that the spaces are actually arranged. Okay, you don't have to sort it in the starting. Okay, this is something important, because normally what happens is, in a medium level question they will not give in a sorted way, so you'll have to first sort it out, because that will also consume some of the space and time complexity. But in this case that is not needed, it's already sorted, there is in a strictly increasing order. Fine. So one thing is, we are good with that. So let's see the question now. You are given a zero index string and a zero index integer array spaces that describe the indexes in the original string where spaces will be added. Okay, each space would be inserted before the character at the given index. Okay, so they are giving the example, you can go through it. They are basically what saying is that you have to go to that particular index and add a space. But remember, one thing that will happen here is, for example, if you see, currently h is at eighth index, but after inserting a space in this index, h will come to the ninth index. Remember that. So that is the only change that is going to happen, and this question is going to test your skills in that. So the change that will happen, you'll have to accommodate that. Okay, that is the only idea. See, after inserting a space here, basically h will now shift towards its right by one position. Now it will be in the ninth index. Okay, so if you see in the answer string, h will now be in the ninth index. Initially in the original string, it was in the eighth index. So that is what is the change here. You will have to take care that those things happen properly and you don't miss anything. So that is the question. You can go through the examples, they're very simple. Since they're very simple, I'm not going through in detail of it. So I will be showing you basically three approaches. Okay, two in Python, one in Java. Let's see how it works. Okay, see, things are very simple here. You can use both, the inbuilt function as well as the, you can do manually as well. Let's see all the cases. So see, first thing I'm going to do is, J will be my pointer. Okay, this is the first pointer that I'm going to use, and I will be the second pointer. Basically, I will be for tracking where we are in the S. Okay, and J will be for tracking where we are in the spaces. Okay, so these are the two pointers that we are going to use. Okay, and these are the storing the length. Okay, these are basically just constants which are storing the length, and will be for storing the length of the given string S, and underscore spaces will be for storing the length of the integer array space. Okay, spaces. Fine. Then we are creating an answer. Remember one thing, that see, in this question, the only thing which I felt is important is that, just try to understand this one point. If you are solving it in Java and Python, you should be very clear about this point, is that, see, strings are basically immutable in Java and Python. What is immutable? Immutable basically means they cannot be changed. That means, let us say I have a string and I want to append something to it. So it's not like you can simply append something or insert something into it. What will happen is, internally Python will create a new string. Python Java will create a new string. That is, it will copy everything from the original string and then it will make that change. So it's not a O of one operation, it will be O of n operation. Remember that. So whenever you're inserting something, deleting something, or appending something to a string in Python and Java, it will not be that simple. It will be a very complex operation, and it will be taking a lot of compute power for that. Okay, so because strings are immutable in Java and Python, remember that. So for that reason, we will never be touching the string as such directly in Java and Python. When I'm showing my solution, I will ensure the same. Okay, so what I'm doing, see, I'm going to use a list here, and in case of Java, basically I'll be using the string builder function. Okay, I will come to that, but let us see the Python solution first. Here I'm going to use the list. Why I'm going using the list? Because here you can append something in O of one time. Okay, you can append, you can change strings, you can do those things in O of one time. Remember that. So that is the best advantage of it. See, in strings, as I mentioned, what happens is, let us say you are appending something. What will happen is a new string will be created. All the contents of the original string will be copied into that, and then the new value will be appended at last. Okay, so it's a very complex operation. It's going to take a lot of time. We don't want to do that. So what we'll do, we'll just get an empty list for now. Okay, then what I'm doing, I'm going through each index of my given string s. Remember n. What is n? N is going to the length of the given string s. So I'm going to go through each of the index of the given string s. Okay, what I'm checking, I'm just checking if j is less than n of spaces. What is that? See, the length of this is going to be n underscore spaces. Okay, n underscore spaces, and j is going to be the pointer which will be pointing to where we are currently in the spaces area. Okay, so first I'm just checking whether I have inserted all the spaces that is marked, that is given to me, or we are it's somewhere in between. Okay, as long as it is less than j underscore spaces, and I is equal to spaces of j, that is, we are at an index where we have to insert a space. Okay, that what it means. Okay, for example, when we reach 8th, this whole condition will be true. Okay, this condition will be true, and this also will become true in that case. Okay, so mostly this part will be, this matters a lot. Okay, this is just for ensuring that we do not cross the limits. Okay, this is the most important part. Whenever we are at the 8th index or the 13th index or the 15th index, as per the example, only then this condition will be true. Okay, in those cases, what we have to simply append a space first. Okay, space will be appended, j will be incremented. Okay, remember, this is inside if condition, so only if the condition is true, those things will happen. Other than that, irrespective of whether this condition is true or not, this particular thing will be done. Okay, what is this? Basically, whatever is there in the ith character of s, okay, that will be appended to my answer. Okay, as simple as that. So what will happen, see, normally I will keep appending all the characters. For example, if you see in the first example, I will keep appending all these characters. Okay, because of this, through this I will be appending all the characters. Okay, in the lead code. Fine. Then we will reach the 8th character. Okay, 8th index. Then what we'll do, we will insert a space using this. Okay, then we'll insert a space using this, and again we will start with this. Okay, help, for example, here you can say helps, and then again a space will be inserted using this. So the space inserting part is done through this. Appending part of the rest of the characters in s will be done through this. Okay, at last, remember, it is in a form of a list, but ultimately the return type should be a string. So what we have to do, we'll have to convert it into a string before returning it. Okay, this is the only thing that we have to take care. You see, it is getting cleared. It's submittable solution. You can submit it, it will get accepted. Okay, now if you're done with this, let us go to the second solution. Second solution is exactly same. We're just going to do more optimization. Okay, it's a very minimal optimization, but yeah, it matters, because if you see the constraints, it's a lot. Okay, it's not like just a string length is not 100 or 200 like that. If that is the case, it is fine to leave it like that. But since the length is more, we will do just one optimization to this. Okay, this part you see in the next solution that I'm going to show you. Just one operation that I'm doing is, see, normally what happens is, when you are appending, right, initially, see, it is defined empty. So whenever you're appending, what will the compiler do is, compiler interpreter, it will do is, it will take a space, and it will take space from the heap, it will allocate it that. Okay, and then the new whatever space allotted in that, the value will be changed to mark this. Okay, as similar that here and here. So that is actually taking some time. So for each iteration, that is for each index of it, so if you see in total how many times you are doing that, it will be the sum of n plus n spaces. Okay, see, the final number of characters in my answer is going to be these two. Okay, n plus n underscore spaces. So for that many times, a new allocation has to happen, and in that allocation we have to change the values. Okay, like this. So instead, to avoid that, what we are going to do is, see, here, while declaring the list itself, I am declaring how many, like total space needed for it. Okay, total space needed for it. So initially I'm keeping it as an empty string, but I am like giving the range as n plus n underscore spaces. Okay, because remember, the final answer will be having a length of this plus this. Okay, as simple as that. So that's why I'm giving it. So initially it will be a list with having empty strings for these many times. Okay, for these many times. And then what I'm doing, see, is here I was just appending it. Okay, here I was just appending it to the you know the list, but here I will not be appending it. Here I have to maintain another index. Okay, this will be a kind of another index that we're using called answer index. Here what I'm doing, what see, whenever the turn comes, I have to, instead of appending, I'll have to change that value now. Okay, in this case, if you see, I'm just going to the answer index and changing this value. Once I change it, I will just do answer index plus one. Okay, same thing here. Here I'm going to the answer index and changing the value here. Okay, previously it must be a empty string, but I'm now changing it to something different, and then I'm just doing answer index plus one. Okay, that's, I'm pushing the index to the next value. So I'm not doing the append anymore, because already things are allocated. I'm just changing the values then and there. But this all remains the same, rest of the code remains the same. These all conditions again remain the same. So this I have solved. Like, this got submitted and it really worked fine. It's slightly better compared to the previous approach. Okay, so the same thing we will now see in Java. In Java, basically, you have the string builder. Remember, in Java the things are slightly different. If you see in Python, we are simply returning it as a string, but here if you see, it is given as a string, but you have to return also as a string. But remember, as I mentioned in the string, what happens is, see, in Python we use the list concept, right? Because in string in both Java and Python are immutable for that reason. So instead here I cannot use a list as such, because I have the functionality to use a string builder. String builder is the best case for this kind of scenarios, okay? Because here you can append the way you want, okay? So I will directly show the optimized approach in Java. So what I'm doing is, first of all, the same thing. I am capturing the length of both the inputs, that is s and spaces. Okay. Then I'm creating a string builder called answer, in which I am assigning a capacity of this. Remember, this is called the capacity of it. That is, this much space will be allocated to it. If you are not mentioning anything like this, that is, if you're leaving this brackets empty, then a default space will be allocated. Remember, it's around 16. You can just can uncomment this part and just print and get to know what it's doing. Okay, maybe you can like remove this thing and then just look at the output of this, then write these two things, that sum of these two things, and see the output of this thing after that. Okay, you will see the difference there. Okay, so if you're writing this, then space allotted will be like this. If you're not writing this, then default space will be allocated. Okay, depending on the version of the compiler or the automation that you're using. As simple as that, right? Rest of the things remain the same as the Python solution. This is the pointer that I'm going to use, and I'm just going through all the indexes on my given string s. I'm just checking whether j is less than n unsourced spaces, and if I is equal to spaces of j. That is, we are at an index where we have to insert a space. In that case, I will just append a space into it, and then I will do a j+1. Okay, in all other cases, what I will do, answer dot append of the character. That is, remember, this condition will be happening. See, this part, the appending of a space will happen only when this condition is true, but this part will happen for all the iterations. Remember that. Okay, so remember one thing, the way we allocate, see, in string builder thing, we use the append function to assign values to that. Okay, in Java, if you see, sorry, in Python, if you see, we are just going to the index and we are assigning the value. But in case of string builder, we are using the append function to do that, though we have already allocated the spaces. But in this case, we are using the append function to go to the next thing and allocate the value, and as simple as that. Okay, remember, this is just the max capacity. This doesn't mean like, see, this is just a max capacity. Okay, it's a standby capacity. That doesn't mean like this much spaces will be there in my string builder initially. Okay, remember that this is just a capacity. As long as you're not causing that capacity, it's good. If you're causing that capacity, it will lead to a performance degradation. As simple as that. Okay, at last I'm returning, remember, you have to return in a string, right? So first, but I'm using a string builder here, so you have to convert the string builder to a string and you have to return it. Okay, I've already submitted the solution and it also worked. Okay, so yeah, that was all, friends. You can just uncomment this and you have to play with it to understand how it works. Basically, string builder is a very very good thing, especially if you're using Java. So try to learn about it. This will solve a lot of your difficulties. And remember, this question especially, what I felt is that in interview, if you talk about the interview perspective, it's very important to understand what are immutable properties in Python and Java strings. Okay, these are very important. Why they are used? Okay, so the question can be like, why it is so. That if it is not going to help us, we have to use string builders for this reason. Why it is so? So you have to know these things basically. So see, the idea here is, see, the immutable property matters when we are using multi-threading. Okay, multi-threading things. Okay, when you're using, the strings are suitable to that. That is, they are thread safe. You have to know these terms. The strings are immutable because they are thread safe in case scenarios where you're doing multi-threading. Okay, you'll have to understand these things, why that is done. That is the reason behind that. Okay, why strings are kept immutable in Java and Python. But these things are not, but yeah, to solve that problem, these things are created so that you can also get that functionality done using these separate classes. Okay, as simple as that. So often, that was all for today. If you like my efforts, please do subscribe to my channel. It really gives a lot of motivation to continue further. So this was all about the day 3 of the December Daily Code Challenge. See you tomorrow. Thanks a lot.